Let's go. Let's go to the next speaker and the last speaker of this morning session. The next speaker is Fabio Baruffa. Hi, Fabio. Welcome to the workshop. You're muted.
Yes. Hi, good morning. Thanks.
Hi. So just a quick introduction. Fabio Baruffa. He is Senior HPC and Quantum Solution Architect at AWS, so Amazon Web Services. And today he's going to talk about Amazon Braket, which is the software development environment that Amazon has developed for quantum computing in the cloud. So thank you for being here again, Fabio. And yeah, the floor is yours.
Thanks. Let's start to share. I think you can see my slides, right?
Yes.
Perfect. Hi, good morning, everyone. And thanks, Ricardo, for the introduction. And it's very pleasure for me to be here and talking about Amazon Braket and how Amazon is tackling the complex problem of providing to customers and researchers quantum computing capabilities. Let's start about what is quantum computing at AWS and how we are making our progresses and what is our main research area. So AWS, quantum computing AWS can be summarized in 4 important pillars that we are moving forward. And the first is the AWS Center for Quantum Computing. That is our lab in Pasadena, where we develop our hardware and our software. And we do research and development in the area of quantum computing and quantum software. Then we have the AWS Partner Network. That is a community of our partners that can help customer research to develop their own solutions. The other pillar is the Quantum Solution Lab. This is a pool of scientists that works hand-to-hand with customers to provide solutions for quantum computing, to develop software. But they have expertise not only in quantum computing, but they have expertise also in high-performance computing, machine learning, AI, so that everything is so all these topics are integrated for providing the best solution for our customers. And then the other pillar is our service, Amazon Braket. That is a fully managed service that runs in the cloud, where you have access to several quantum computers and simulators through AWS cloud infrastructure. So the AWS Center for Quantum Computing, actually, we opened the doors of this building in October 2021. There's also been an announcement recently where we work with the leading experts of quantum computing to develop the processor and the software. This is based on the Pasadena. This is really a building close to universities. So this is a pool of hundreds of scientists that are working together to the goal of developing a full tolerant quantum computer based on superconducting qubits and the software. So we try to build directly from the beginning an error-corrected qubit. A bit more words about the Quantum Solution Lab. This is as I mentioned, this is a pool of scientists that we have at AWS that they do collaborative project and engagement with customers. They identify applications, potential use cases, and go deep dive with the customers regarding science and quantum computing. So they are also providing, for example, benchmark algorithms and the dedicated solution that is integrated within the AWS cloud, leveraging all the potential and all the services that we provide. So this Quantum Solution Lab also can be engaged to build the internal expertise. If there are customers that needs to be trained or needs to be find the best strategy to build up a team that works on quantum computing, this is also the team that could help. And the main topic that they are working are machine learning, quantum computing, and HPC. because we think those are all integrated. These are all integrated in the same computing capability. And so this is really a pool of scientists and experts that we can offer to our customers. So here is a selection of our partners and startups that they focus solution with Amazon Web Services. And this list keep expanding month by month, where we find new partners. This means that the list here is all the partners and startups that are building solutions on top of Braket. And some of these names are already known for you. Some might be new, but those are the one we work with, and they provide the best experience to the customers. And then the important pillar here is our service. So the Amazon Braket is a full managed service. So that means we manage all the infrastructure, we manage all the software installation. What we provide is an easy access for scientists and developers to explore and test the quantum computer. So with Amazon Braket, you are able to build your expertise. You are able to build your algorithms in different flavors. So you can use a command line interface. You can install the Amazon Braket SDK to your environment. You can use Jupyter Notebook, and so on and so forth. Underneath of that, you can, after you build your application, then you would like to test it in a noisy-free on a noisy environment. And we provide simulators here. So this can help for rapid prototyping and testing of your idea or of the algorithms. We provide also access to several quantum computers, and I'm going to give you a bit more details in a few slides, where with our partners, we provide access to a Niles computer, a Gate quantum computer as well. And in the end, once you run your application, you will be also able to monitor the algorithm and the results and analyzing using the tools from AWS. And let's start with Amazon Braket. So let me give you a brief introduction about that. So Amazon Braket is a service integrated with AWS Cloud. So that means you can leverage, using Amazon Braket, you can leverage also other services that maybe you might be familiar to from AWS. For example, here you see boxes here around that. There is AWS Cloud, and Amazon Braket is one of the services that we offer. It's the service for quantum technology and quantum computing. So this Amazon Braket can be used using with other services as well. For example, you can store your results in the cloud using the Amazon S3. This is the storage access through the cloud. Then you have all the security and all the management of your account, and also for your code. So you have the security in place with the services like AWS Identity and Access Management. And the interesting part is also the notification. So for example, you run your application and you would like to monitor what's going on or get a notification if the job has been executed or not, then you will get some notification, and also monitoring, right? So you could monitor what's going on while your application is running. And in the center box, you see that is managed simulators, and this simulator. So on top of that, we have also the quantum hardware that you can have access to. On the left side of these slides, you see the user perspective, how the users interact with Amazon Braket. So you could, for example, install on your local laptop the IDE, so the SDK, the Amazon SDK, and then you can work locally, and at the end you submit your task, you submit your work, and then you will be queued on the Amazon Braket, and you can monitor this through it's an Amazon Braket console. Or if you prefer to use directly the cloud, we offer the managed service notebook, Jupyter Notebook, where everything is already installed and managed by AWS. So you just go there, do your development, and submit your task. Regarding the simulator, we offer local simulator and the managed simulator. The local simulator is the one that we provide in the SDK, and this local simulator is a pre-install on the Braket SDK. I can do state vector simulator with and without noise. Of course, this is a limited simulator because it depends on the number of the hardware that you are running on. So the number of qubits, it really depends on the amount of memory you have. But on the other hand, we have managed simulator that can leverage the HPC capability. So we have the state vector simulator. Then we have the tensor network simulator and the density metric simulator that allow you to play with the noise. And this is everything. Everything provided in the same development environment. Regarding the hardware, we have several hardware that we provide. So this is the quantum annealer from D-Wave, from annealing problem, as we have learned today as well. Then we have trapped ions provided by IOQ and superconducting qubits provided by the Jetty. And if you have heard the news, actually, a week ago, we have announced the expansion of our hardware offering. So we are working with the Oxford Quantum Computing, and we are going to provide to our customers and researchers the possibility to use this hardware in integration with Amazon Braket, and the same for the QA, that is the Rydberg atom out of atoms. Important thing is that from the Oxford Quantum Computing to mention is that this will open up the possibility for Europe as well, because we open up a region in the European time zone. That means you could also use this on your time zone. The interesting part about the integration, and this is just a very synthetic here, is that the integration comes not only from the infrastructure, but from the user's perspective in the simple Python language. Because when you run your circuit or you define your algorithm in a Python script, you could leverage several devices. This device is an abstract object that can be either a simulator or a quantum processor unit. And what you need to do in your application is just to change the line here that is highlighted that specifies the device. You give there the Amazon resource name that allows you to identify the selected device, and then you run it, the same code and the same application on different devices. That means either on the simulator or several QPUs. Another important update that we have recently is the possibility to hybrid job, and this is a new service feature that has been announced a week ago. What is hybrid? Hybrid is the possibility to do classical quantum algorithm in the same environment. As you have learned, variational algorithms can be the QAOA or the variational quantum eigensolver and others. They are algorithms that leverage the classical computing and the QPU for certain calculation. For example, you have a parameterized circuit and it needs to change, and some of the value and some of the encoded can be done directly on a QPU. Then once these parameters are adjusted, then there is an objective function that needs to be evaluated, and this will be done on the CPU. The hybrid algorithm is very it's very promising for the near-term quantum computer now, and this is a similar of what is done, for example, in high-performance computing with offloading computation to GPUs. In this case, you can think a QPU like a coprocessor where you offload some part of the computation. What we have released right now is the possibility to do hybrid job, and let me explain to you a few concepts before you could get what I mean here. So we have definition to understand that, you have the definition of shots and tasks. A shot is a single execution of a quantum operation on a device. So there can be a circuit like here on the left part of these slides. Then the task is a series of repeated shots on a particular device. And this is important because this is the way you can leverage and have the results in a quantum computer. So what you do, your task is a series of several shots that collect statistics and collect the results that you are looking for. The hybrid job is a sequence of classical and quantum computer cycles. So what is happening here is that the classical computer is working hand-to-hand with the quantum computer. So what it means right at the moment, what is the big difference here? When you submit your task, that is a sequence of shots, then this task will be queued and then will be executed on the quantum computer once it's available. But if you have an hybrid job where the classical computer and quantum computer needs to be working hand to hand, for example, in an optimization process or in a variational problem, then you need to reserve the time for such kind of computation to work together. In this case, you submit, instead of task, you submit a job, and then you reserve the access and the classical computation for this job exactly. And this could reduce the latency of accessing the quantum processor through the task. And this is the way we have leveraged the hybrid jobs. The hybrid jobs allows you to two things. One is to have dedicated resources for classical compute. And second is to have a dedicated resources for quantum computer that works hand-to-hand with your classical approach. And this allows you to do seamlessly the hybrid algorithms. How this actually works, from the user perspective, you create a job instance, and this instance can be this instance is what you define. And this can be, for example, provided by containers, provided by script. And then in this job instance, you specify what you want. If you want a managed simulator, or you might have a QPU or quantum hardware. And everything is integrated through services like Amazon S3, that is the storage, the CloudWatch for monitoring, and the Elastic Container Registry, that is the Amazon service for managing containers. So what you do is the classical compute that manage the hybrid job. What you need to provide is so there are 3 ways to pre-build the containers that we offer. So what you do is you just bring the container with your application. This container will be stored in the Elastic Container Registry. And then while it's done, so you could, in the meantime, monitoring the algorithm through the Amazon Braket console. The important point is the priority access to the hardware, because once you submit your job and the job will be executed, you will be the only one that at this moment, while the job is running, will have access to the quantum computer. So that means you reduce the latency to get access, and then it will be released after your job has been finished. So because as you might have experienced, or maybe with some of the workshop or some of the task you have done with Amazon Braket, is once you submit your task, the task is queued, and this hardware is might be available by others as well. So in this case, your queue time might be long. On the other hand, once you submit your job, once the job is in the queue and then it is in the running state, you have exclusive access to quantum hardware, and then you can reduce the waiting time for accessing the QPU, and also reducing the time to get your solution done. And the next part is how to build with Amazon Braket. So Amazon Braket is, as I mentioned, is one of the more than 150 services that we have at AWS. And that means you can think beyond that. So it's not only we provide the quantum technology, of course, together with other services. So that means you could prepare your application and integrate with other services as well that could leverage a complete solution hand-to-hand from beginning till the analytics of your results. in the same infrastructure, because in the same infrastructure we managed the quantum resources and the classical resources. And this can be an advantage for all our researchers and customers, that in one place they can have the classical compute and the quantum compute on top of all the services that we already offer. This is just an example of a custom API that you could build. So you have a service called Amazon Cognito that is the identity identity for a certain selection of users. For example, you could provide the service itself, and providing a selection of API that could access, for example, the Amazon Braket or the classical compute. So just an example of how you could potentially use other services that we provide from AWS. And the Amazon Braket is also, since the near-term algorithm are also in the space of HPC and machine learning, HPC in terms of simulating quantum circuits and machine learning. So with other services, you might be able, for example, to use the analytics service or the databases to store your results, and also doing machine learning pipelines together in the same environment. And the last part is, how do we get started? So if you would like to learn more, or you get it guided with Amazon Braket, so we have several examples through our GitHub repository. So these are Amazon Braket examples that you can download and play with. You can start also to install locally your Amazon Braket SDK to get started and get familiar to the way you could develop your applications. Then we have integrated for easy access to a library called PennyLane. That is a library for programming quantum computers, quantum machine learning, and also quantum chemistry. And this is you could also see the tutorial from PennyLane. We have provided a plugin that allows you to work together with to work on Braket SDK together with PennyLane. In case you would like to start, so there are two ways. So one is you could open the AWS account, and then from that you had 1 free hour per simulation time per month. So you have this is part of the AWS free tier, and this is quite interesting for experimenting if you would like to do that. Or we have also the possibility to apply for cloud research credit. So in this case, if you have a project and you would like to experiment with the quantum computer, so you just go here, apply, and write a small project statement and what you would like to achieve, and the amount of credit that we can grant, and this will be reviewed and then approved by AWS. So these are the ways to access. We have also special partnership with also with Chineka, where we have done several trainings this year, and also the possibility to through Chineka also to access this Amazon credit for research. And then I stop here. So and thank you for your attention, and I'm opening now for Q&A.
Hi, thank you very much, Fabio, for this great overview and great news from Amazon side.
Thanks.
I see one question in the chat, which says, could this job be submitted to Amazon Braket via Amazon Lambda?
Yes, I think everything can be. Everything is integrated in the same environment. So you could create a solution that triggers a Lambda. So what, for example, you could do is, like, you upload your, theoretically, right? I just, as a solution architect, I also like building new stuff. In this case, you trigger one idea that could be, for example, you have your circuit, your code, you upload to this to S3 bucket. This S3 bucket trigger a Lambda, and this Lambda triggered the job that will be submitted, and then and then at the end you have another Lambda that could trigger the results. I think these are the potential. That's the reason why the integration with other services can give you the potential to really invent solutions that allow to speed up your journey? That yes, I mean the short answer is yes, and this is actually what we are looking after when we want to work with the customer researcher. So that's a nice question.
Great. So other question from the chat, or let me see if there are also on YouTube. Okay. You said, okay, you have this new part, this hybrid part that you developed recently. So I think probably, as Federico said, IBM goes like probably something similar to what he said, what IBM calls IBM runtime, Qiskit runtime. Okay, so but I think, I mean, my idea is that right now a lot of approaches go in the lot of short-term NISQ approaches go in the direction of hybrid variational algorithms. So it's like important to reduce as much as possible the latency between classical and quantum. So is it also possible to let's say test this hybrid part, which is it already in Braket?
Is already available. Is already available in the Braket. So I actually I think it was short on time. I wanted to prepare a demo, but for this short time, it might be not ideal. But yes, this is already available. And if there is someone interested on that, so that would like to leverage, just keep in touch with us, also with you, right, Ricardo, and then we can follow up later.
Yeah, and
this is available on that. So
yeah, my idea was, okay, maybe let's say we can also use the same software, the same hybrid software to launch something, let's say, that use your QPU and probably the HPC system that we have here at Cineca. So, and like something that mixes the two. Do you think is it something possible to do, or?
Good question. I don't have the answer now, but let's brainstorm. Let's brainstorm and see what can be done. But this is right now. Since this is integrated in the EC2, this is the elastic cloud compute that we have. So you define how much. I mean, you define how many cores, how much memory you want for the classical part, and then which CPU, which quantum processor unit. Then you submit your job, and then the job will be queued. And once it's done, you have the two resources are ready there, and then will be done this job. It's nice to experiment. I think there will be a lot of a great idea, Ricardo, that that can be explored. But yes, I think that's it's a good learning. I mean, we just started. You know, everything is of course, it's going with different speed and also going in different directions. But again, the journey just started for everyone, and this is interesting to see what can be done in the future. So even if this is the way the researcher would like to see. So we also work very close with the researcher to get feedback if this solution or this kind of service is the one that they prefer, or they prefer a new feature or prefer other things. This also can be part of the work with AWS.
So let me ask you another question from the chat. So is there any work in progress or on standardization across quantum as a service from different cloud providers?
I don't know. Actually, that's a good question. What we are trying to do in AWS is the following. So we have how maybe the question might be how we are working with other partners to get the AWS cloud rich with different QPUs. Actually, what we do is the first. First, we see on the market and we see on our research what are the QPU that are mostly asked. Okay, that's why we have started the service with D-Wave, rejected IonQ. They are quite mature, and there's also we have users and researchers asked. Then we expand. So we try to expand the offering. That's why we have seen that we have offer now from Oxford, and we have also from Ligbert Atoms for the special processor here. So this doesn't exclude the possibility that we work with other partners and get it integrated in the cloud. The same also, we are working on our processor, and this will be also provided in the same way. So in the unified environment with the software that is Braket and unified cloud environment, we try to work with the partners and make this as accessible. So this is how we work and how we are, how we work and how we think about integrations.
Thank you very much, Fabio. One very last question, because otherwise it's going to be too late. Is Amazon working on developing its own quantum computers?
Yes, I think I can confirm that we work on our quantum computer. So they've been, if you are interested to learn more, just thinking I can share all the information. So we have a research paper that is actually the hardware that we are developing is almost in 90 pages of archive paper, quite interesting one. So I can confirm. So we work on superconducting qubits and error-corrected qubit directly from, and we use a special CAT qubits development just to reduce the dephasing and on the device. Again, this is a long journey, as you know, but this is something that we have announced also 1 week ago during our reInvent, and yeah, this is very exciting.
Yeah, it's public right now, so okay, we can confirm. Okay, so thank you again, Fabio.
Thanks, Riccardo. Thanks, Daniele.
Thank you for being here. Great presentation and great news. I think okay, we reached the end of the first session of the first day, and yeah, we can go to lunch, and we're gonna see each other in 1 hour at 1:15.
Yes, exactly. Thank you, Riccardo. We will see each other in 1 hour with another session about the relationship between QC and HPC in Europe. Thanks a lot. See you in 1 hour.
Bye.
Bye.